Today we will be studying Insert chapter number 7, Congruence of a triangle. Guys, you need to pay attention in particular to this chapter, as this is a kind of an important chapter for the examinations. See, what is congruence? The relation of two objects being congruent is a congruence. Loud say. Now let's consider the lines. Yeah, this is my line AB, which is 5 centimeter. And now I have another line APQ, which is again a 5 centimeter. So now I can say line AB is congruent to line line PQ. Yeah. Now, why I am saying congruent? Now, if I pull line AB here and I put it on the PQ will be completely covered. So these two lines are identical. Why they are identical? Because their measure is exactly same. So line AB is congruent to line BC. So that in terminology we can say length AB, segment AB, this is the sign of congruence. Congruent to segment PQ. Yeah. Now let's take another example. This is my line CD, segment CD. This is my segment, since I am not continuing for the picture segment. And then my another segment is XY. This is 10 centimeter and this is 10 centimeter. So now what I am going to say, segment CD is congruent to segment XY. Yeah. So now we know how we can say lines are congruent to each other. Now let's see the angles. This is my angle. This is A, this is B, and this is C. And I have another angle P, Q, and here the R. This is 40 degree and this is as well 40 degree. So if I take this angle from here and place on this, I'll be able to cover it. So now these two angles are congruent to each other. So angle B is congruent to angle Q. Here it might be case that here you are this might be arc may be of a small length, even if this is of this length, still these two are congruent. We are saying congruent angle. So the angle B is congruent to angle C. Or in other words, if I have a right angle here and then I have a right angle here, this is, if this angle is a B and if this angle is a R, so I say ABC and here I say PRQ, then angle B is congruent to angle R. Now this is either, when I say angle B congruent to angle R, that means both the angles measure is equal. Now let's check for the triangle. Now say if I have a triangle of this shape. This is my A, B, C. Then I have another triangle. More or less P, Q, R. Now if I take this P, Q, R and put it on the ABC, the ABC will be completely covered. So they have these two triangles are identical in all terms. So now I can say triangle ABC congruent to triangle PQR. Yeah, so ABC is congruent to triangle PQR when they are exactly same. Now when I say congruent to, so what will happen? Length of, so they are corresponding. So length of AB will be corresponding, or we say let's say corresponding vertices. Vertex A corresponding vertex. See, now the thing is, now if I want to check, that ABC and PQ are congruent or not. So now if I put P on the C, will my this figure close to ABC? Won't. If I place P on the A, Q on the B and R on the C, then only the figure PQR is going to cover completely figure ABC. If I put R on the A, that's not going to happen, because then if I do that way, some part of the B will not be covered. Okay. So now the corresponding vertices. Which are the corresponding vertices? If I put A and B, so my A and B are the corresponding vertex. Then my A and P is the corresponding vertex. So if I put P on the A, it will work. Second, my B and Q are the corresponding vertices. So if I put Q on the B, it will cover. And the last one, my corresponding vertex is C and R. Yeah. So if I put P on the A, Q on the B and R on the C, I'll be able to cover triangle ABC with the triangle PQR. So these are my corresponding vertices. Now when I put this on the corresponding vertices, I will also well able to find corresponding sides. Yeah. So my AB is AB and PQ are corresponding. So if I put PQ on AB, I'll be able to cover the A triangle ABC. So this and this is corresponding. Comma, then my AC is correspond to the PR. So my segment AC is correspond to PR. The last BC is correspond to BC corresponding pair will be QR. So now if I put this one here or this one, or if I say I measure this and draw a line here, I measure this and draw a line here, I measure this and draw a line here, I'll be able to build a similar sort of a triangle. Exactly same measures. Now another thing what we have in triangle, that is angles. So corresponding angles. Now see, here my B is right angle, here Q is right angle. So my angle B and angle Q are corresponding angles. Now my angle A and angle P are corresponding angles. Angle A and angle P are corresponding, and angle C and angle R are corresponding. Angle C and angle R are corresponding. So now like say, if I want to place my this hand on this hand, if I put this one, so what is happen? My these two figures are corresponding figures. If I try to put this one, they won't, I won't be able to close my left hand with the right hand. If I put this way, this one. So when I close my left hand with the right hand side, these two thumbs, they are corresponding. These two are corresponding. These two are corresponding. These two and these two are corresponding. That way, when I put a triangle PQR on triangle ABC, these are the corresponding vertices, corresponding sides, and corresponding angles. Now say, now they appear to be same. So now if I draw something like that, say this is my triangle, this is my one triangle, and then I have another triangle. So now if I say this is correspond to this, this is correspond to this, this is correspond to this. So here I will be able to check whether these two triangles are congruent or not. Unless and until I don't know which are the corresponding, I won't be able to check whether they are congruent or not. Now let's revise the concept which we learned before. Now say let's consider this example. My triangle ABC is congruent to another triangle PQR. Now I want to write which are the corresponding vertex, segment length, sides and the angle. So now corresponding vertex will be corresponding first vertexes. Which are vertex corresponding? Vertex C. Here my direction is A, B, C, P, Q, R. So A is corresponding to P, B is corresponding to Q, B and Q, and then C and R. C and R are corresponding. Now second, sides. Now AB, here AB is and PQ are corresponding. Then BC and QR are corresponding, and AC and PR are corresponding. And now the third is an angle. So now have again angle A is and angle P are corresponding angles. Angle B and angle Q corresponding angles, and angle C is correspond to the angle R. So now when I say triangle ABC correspond to triangle PQR, that doesn't the sequence, the exactly which are corresponding vertex and sides are in the same sequence, irrespective of how the figure is placed. Yeah, you can't say AB, now here something else. Yeah, so when we say triangle ABC is corresponding to congruent to triangle PQR, that means vertex A is corresponding to vertex P, vertex B is correspond to vertex Q, and vertex C is correspond to vertex R. In the same sequence, the vertex will be correspond, and in the same sequence, the side will be correspond. In the same sequence, the angle will be correspond. Yeah. Now, let's say this is my one angle. Angle A, triangle A, B, and C. Here, the another angle PQR. The length of AB is 5 centimeter. This is 7 centimeter, and this is something 10 centimeter. And here 5 centimeter, 7 centimeter, and 10 centimeter. Yeah. Now, what will you say? These two triangles are congruent to each other or not? If I place this here and here, so I am placing point vertex A on B, so it will cover this 5 centimeter, 5 centimeter will be covered. Q to CR is 10 centimeter, B to C is 10 centimeter, so this centimeter will be covered. And P and R 7 centimeter and 7 centimeter. Yeah, so I'll be able to say triangle ABC is congruent to triangle PQR. But how I managed to say this? Because the sides, three sides of both the triangles are same in length. So we say a length CB equals to length PQ which is equal to 5 centimeter. Length BC, or we can say BC equals to QR, which is 10 centimeter. And AC equals to PR, which is equal to 7 centimeter. Yeah. So now my length AB is and PQ are corresponding. My BC and QR are corresponding. My AC and PR are corresponding. They are identical. So triangle with, if I have three sides of triangle equal, then I can say two triangles are congruent to each other. Yeah. So if I'll write, if under the given correspondence, if the three sides of one triangle, three sides of one triangle are equal with equal to the three sides of another triangle then the triangles are congruent. Yeah. So now this is your, see, the first criteria what we learned is a side, and side. This can be alternatively written as S. So the sides of all sides of corresponding triangles, if they are equal in length, then we can say those two triangles are congruent to each other. So this is our first criteria, is a side, and side. I am purposefully writing it over here. So let me so we need to remember this, because when we need to prove whether, so our first is side, and side. So if someone gives us information, if someone tells us the length of three sides of two triangles, then we can say whether those triangles are whether those two triangles are congruent to each other or not. So the first criteria is a side. Now let's pay 100% attention to this example. Now say what they say, in figure AD equals to CD, AD is equal to CD, AB is equal to CB, AD equal to CD, AB equal to BC. Yeah, and we need to answer these three questions. What the first question is, let's start the solution here. The first one, what this is, take three pair of equal parts. Two they already given us. Yeah, so now first AB, we write it as AD equals to, see, what say, A and D. Triangle is A and D. So here we say C and D equal to CD. Why this is? Because it's a given. They themselves given. Then AB is equal to CB. How we know? Because it's given in the problem. So we say given. Now BD is in this triangle as well. ADB, this triangle the BD is there, and CDB, again BD is there. So BD of this triangle is equal to BD of the corresponding triangle. Yeah, so we say as common side. Yeah, so now we solve the first part, three pair equal parts in this triangle. Now the second one, what they say is triangle ABD is congruent to triangle CBD. So what we say, from ABD and triangle ABD is congruent to triangle CBD. Triangle CBD. How come? Since three sides are equal. So we give a reason by SSS rule of congruence of triangle. Side. So now we sorted out the second one. Now the third one. See what we have proved now. Triangle ABD is congruent to triangle CBD. So when two triangles are congruent, their corresponding vertex, the corresponding sides are equal, as well as their corresponding angles are as well equal. Yeah. So now, which are my corresponding angles? If you see my triangle, so angle A and angle C is corresponding. Then angle B and angle B is corresponding. Here, angle B also okay. I'll write it in the complete form. So now if I say my ADB, angle ADB is corresponding to the triangle angle CDAB. Angle CDB. So my these two triangles, okay, no problem. Here these two angles are corresponding. Now my angle DAB and DCB are corresponding, so they are equal. And my angle ABD and CBD, angle CBD are equal. So here I say they are equal, or I can say triangle equals, to have a better understanding rather than and saying equal. Why? Because those two triangles are congruent triangle, because triangle ABD is congruent to triangle CBD. This is the reason 3 times, and those are the corresponding angles. So now ABD is equal to CBD. What they say now, the third question, does BD means BD is bisect ABC, A, B and C. Does it bisect? Yes, because angle ABD and angle CBD are equal. So we say yes, we say BD bisects angle ABC. Why? Because as angle ABD equals to angle CBD. And why angle ABD is equal to CBD? Because they are corresponding angles of congruent triangles. Got it? So here this one you need to understand neatly. The rule which we use to prove these two triangles are congruent is side rule. Now let's look at this example. In figure, state whether the given pair of triangle is congruent or not. Now we need to prove whether they are congruent or not. So now ABC, they have given us the length of each side of the triangle. So what we need to prove, whether ABC is congruent to PQR or not. So what we'll do a step. Now onwards we'll be solving problem in this kind of a fashion. In here it will be a reason. Yeah. First step. AB is equal to PQ equals to 1.5 centimeter. How we come to know? Because it's a given. Yeah. Second, PC equals to QR equals to 2.5 centimeter. How we come to know? Because it's given in the problem itself. Now, third, AC is equal to PR is equal to 2.2 centimeter. How we come to know? Because this is given. So now fourth step we say triangle ABC is congruent to triangle PQR. On what basis we are saying? By rule of congruence. Side, side, side. Or you can simply write SSS. Yeah. So in this fashion, we'll be checking individually each step, and then we'll confirm whether our rule which we learn sides, whether it states true or not. Since the three sides of both the triangles are identical, we concluded that triangle ABC is congruent to triangle PQR.